Imagine waking up to an empty lot, a blank canvas of possibility, and then going to bed the very same night with a brand new, fully constructed house standing proudly there. A tangible dream realized in a single day. Back in 2018, Icon, a pioneering company in construction technology, turned this dream into reality. They used a giant 3D printer, a marvel of engineering, to build a 650-square-foot house in Austin, Texas. A modest yet fully functional home, showcasing the potential of this groundbreaking technology. And the truly astonishing part? It was completed in under 24 hours for less than $10,000. A fraction of the time and cost associated with traditional construction methods. This wasn't just a scaled-down model, a mere proof of concept or a prototype for demonstration purposes. This was a real, livable home, complete with all the essential amenities, including fully functional plumbing and electrical wiring. A testament to the practicality of 3D printed construction. That moment shattered the long-held idea, the preconceived notion, that 3D printing was solely limited to creating plastic toys and trinkets. Now, the focus has shifted dramatically. It's about scalability, the ability to produce on a large scale, speed of construction, and overall efficiency in resource utilization. Building directly from a precise digital blueprint, eliminating the need for manual interpretation and reducing errors. This process requires no traditional molds or complex assembly lines and generates almost no waste, contributing to a more sustainable construction industry. Think about the implications for disaster relief efforts. In the immediate aftermath of a devastating hurricane, you could potentially print durable and safe emergency shelters in a single day, providing rapid assistance to those in need. Or consider the possibilities for addressing the global affordable housing crisis. 3D printing offers a pathway to rapid, cost-effective construction of durable homes, making homeownership more accessible to a wider population. The very same core technology that allows you to print a customized phone case can be scaled up exponentially to print an entire house layer by layer with remarkable precision. In this exploration, we're going to break down exactly how this revolutionary process works, examining the different types of printers currently being utilized, and showcasing some of the incredible structures that are already being built around the world. If we can achieve the feat of printing a complete house in a single day, then the real pressing question that we need to address is, just how profoundly and rapidly will 3D printing technology reshape our world and change everything we know about construction and beyond? Let's dive in and explore the fascinating world of 3D printed construction. Have you ever wondered how a 3D printer can conjure a tangible object from the ethereal realm of a computer file? It seems like something out of science fiction, but it's a very real and increasingly accessible technology. The journey begins with a digital model, meticulously crafted using CAD, computer-aided design software. These powerful programs allow designers to sculpt and refine their ideas in a virtual space. Alternatively, you can explore vast online libraries and marketplaces where a universe of pre-designed 3D models awaits, ready to be downloaded and brought to life. This digital file is more than just a pretty picture. It holds every minute detail of the object, its precise shape, overall size, and internal structure. It's a complete blueprint for the printer to follow. Next, specialized slicing software takes center stage. It cleverly dissects the 3D model into hundreds or even thousands of incredibly thin layers, like the pages of a book. This software then translates these layers into G-code, a precise set of instructions that the printer can understand and execute. The 3D printer diligently reads the G-code and embarks on the construction process, building the object layer upon layer, in a process known as additive manufacturing. This is commonly achieved by melting plastic filament and carefully extruding it through a precision nozzle. Each newly deposited layer meticulously fuses to the one below, slowly but surely stacking up, transforming into the desired 3D object. The printing process can span anywhere from a few minutes to several days, largely dependent on the object's size and the complexity of its design. Once the printing is complete, you might need to carefully remove some support structures that help during the build, but generally, that's all there is to it. And just like that, you've successfully transformed a digital concept into a tangible physical reality. It's a form of digital magic, where creation happens one layer at a time, revealing the wonder of 3D printing. That encapsulates the core essence of 3D printing technology. Now let's delve deeper and explore the main types of 3D printers available today. There's more than one way to 3D print. FDM is the most common melting plastic filament and building objects layer by layer. It's affordable and great for prototypes or functional parts. SLA uses liquid resin and a UV laser for ultra-detailed smooth prints perfect for jewelry, dental models, and miniatures. SLS works with powdered materials, fusing them with a laser. It's ideal for complex interlocking parts and doesn't need support structures. DMLS takes SLS to the next level, printing with metal powders for aerospace, medical, and industrial parts. Each method opens new possibilities, from home gadgets to rocket engines. The right printer depends on what you want to create. Let's see what people are building right now. 3D printing is transforming industries. In medicine, doctors use printed models to plan surgeries and create custom prosthetics tailored to each patient. Engineers can design, print, and test prototypes in a single day, speeding up innovation. Even food is being printed. Custom chocolates, soft meals for patients, and plant-based meats with realistic textures. Manufacturers print custom tools and parts on demand, while small businesses create niche products without huge upfront costs. From replacement car parts to architectural models and even entire houses, 3D printing is everywhere. It's not just a hobby, it's a revolution in how we make things, and it's only getting bigger. But how is it changing manufacturing itself? 3D printing is shifting manufacturing from massive factories to local, on-demand production. Traditionally, making one item was expensive. Factories relied on mass production and global supply chains. With 3D printing, making 1 or 100 costs about the same. Need a spare part? Download the file and print it locally. No warehouses, no shipping delays. This digital inventory model makes supply chains faster, cheaper, and greener. It also enables true customization products tailored to each customer, like custom-fit earbuds or eyeglass frames. Anyone with a good idea and a printer can launch a business from their garage. The future factory might be a network of millions of printers worldwide. Manufacturing is becoming democratized. So what's next for 3D printing? The future of 3D printing is poised for remarkable advancements. We're on the cusp of a new era where speed is paramount, transforming how we approach manufacturing and production processes. Innovations in new materials are set to revolutionize the industry, and smarter machines will drive efficiency and precision to unprecedented levels. Next-gen printers like CLIP, which stands for Continuous Liquid Interface Production, can now print objects in mere minutes, a stark contrast to the hours it used to take. This leap in speed is a game-changer. Soon we'll be able to print with a range of exotic materials, seamlessly mixing hard and soft elements within a single print, or even embedding electronics directly into products during the printing process, opening up new possibilities for smart devices and integrated systems. And the concept of four-dimensional printing is rapidly becoming a reality, envisioning objects that dynamically change shape when exposed to stimuli like heat, water, or even light. Artificial intelligence will play a crucial role, designing complex and incredibly efficient structures, and meticulously monitor prints in real time, ensuring quality and precision every step of the way, significantly reducing errors and minimizing waste in the production cycle. The field of bioprinting is also advancing at an astonishing pace. Scientists are now capable of printing functional tissues, intricate blood vessels, and are even diligently working toward the creation of fully functional organs for transplant. Looking beyond our planet, in space, astronauts will soon be able to print essential tools and replacement parts on demand, utilizing locally sourced materials found on other celestial bodies, ultimately making sustained off-world living a tangible possibility. 3D printing isn't just about the simple act of making things, it's about pushing the boundaries of what's achievable and making the seemingly impossible possible. The next wave of innovation will blur the line even further, increasingly blurring the lines between the realms of science fiction and tangible reality. In this exciting future, the only true limit is the scope of our own imagination. So, with all these incredible possibilities on the horizon, what do you think the future holds? We've explored how 3D printing works, the tech behind it, and its impact on everything from medicine to manufacturing. This isn't a passing trend, it's a foundational shift in how we create. The technology is getting faster, cheaper, and more accessible every day. What excites you most? Custom products, medical breakthroughs, or space exploration? Have you tried 3D printing? What did you make? Drop a comment below and share your thoughts or questions. Your ideas help shape the future of this technology. Let's keep the conversation going. Peace.